So when you put an acid and a base together in solution, they're going to do something that we call neutralization. The acid and the base will neutralize each other, and you end up making water out of those two things. And that's going to make sense if you think about the definition of the acid and the base. Remember that acids add hydrogen ions to the solution, and remember that bases add hydroxide ions to the solution. So if you think about a solution where both of those things are present, then the hydrogen and the hydroxide get together and they make water. So we have something that looks like this. Now that's not really the complete chemical reaction, because this hydrogen would have an anion associated with it, and this hydroxide would have a cation associated with it, and so there would be another product over here. So let's look at a really simple example where we have hydrochloric acid and sodium hydroxide. Now one of the skills that I would like you to be able to do regarding neutralizations is to be able to write these chemical equations. And it's fairly simple because you already know one of the products. You know that this hydrogen and this hydroxide are going to combine to make water, and that's just a given when you have a neutralization reaction. Now the other thing that's going to happen then is that our hydrogen and a hydroxide have been used now. Now the sodium and the chloride will combine to make our other product. And if you're really thinking about this hard, you will recognize this as a double replacement reaction. So a neutralization is really just a special case of that double replacement reaction that we learned about quite some time ago. So always we're going to take this cation and this anion and put them together, and this cation and this anion and put them together. Now, as long as you have a solution that is still a solution, that's still water, these two things will not actually go together like that. They will continue to be dissociated and separated from each other in the water. But if you were to evaporate the water out, you would end up with salt. And you might remember that we actually did that in a lab a while back. We added these two things together in a beaker and stirred them up, and then we left them on a gently warming hot plate for a number of hours, and the next day you came in and you had your beaker full of salt, and we weighed it. So you've actually seen that reaction. But every time you write a neutralization, you're going to do it the exact same way. You find your hydrogen and your hydroxide and put them together, and then just combine the other two things. Now, in this case, we have a positive 1 and a negative 1 ion that go together in a 1-to-1 ratio. But don't forget, if you don't have that, if you, for example, had maybe a calcium and a chloride, you would need to write the formula for that correctly, like you learned to do earlier this year. All right, so let's look at doing some math with this. We've done a titration already, and I had you do the math in a way that was very similar to the way that you'd already learned how to do stoichiometry. But I'm going to show you an equation now that we can use for titrations, and that's the molarity of the acid times the volume of the acid equals the molarity of the base times the volume of the base. I want you to understand why this equation works. It works because we're setting moles equal to moles. And if you remember, when we did that experiment, that titration that we did in lab, we talked about the fact that when that flask turned pink, that was our indication that we had equal number of moles of acid and base, because that pink color came from us just going over the edge to getting just enough base in there so that we could see the color. So it was essentially equal number of moles of acid and base. Now, molarity, what is that? That's moles per liter. Volume, that's measured in liters. So if we cancel those two things, we have moles of acid on this side of the equation, and similarly we have moles of base on that side of the equation. So when the moles of acid and the moles of base are equal, we stop our titration, and then we can use the values from the experiment to figure out what's the molarity of the acid. So let's just make something up here and say that we've got a titration going where maybe we have HCl in our flask, and we have 100 milliliters of that in the flask, and we don't know the concentration. So the molarity equals question mark. We don't know that. That's what we want to know. And then in the burette, we have some NaOH. And we know that we have 0.02 molar NaOH in our burette. And we know that we used 22.50 milliliters of that in order to do the titration. And after we added this much, that's when it turned pink. So using these numbers, we can fill in what we know. Now this is our unknown. The molarity of the acid is what we're going for here. The volume of the acid was this 100 milliliters. The molarity of the base is given as 0.02 molar, and the volume of the base is 22.50. Whoops, not molar, milliliters. Now a minute ago I talked about the volume being measured in liters, and that's true, but if the volume is measured in milliliters on both sides of the equation, technically I ought to convert that into liters so that it will cancel with the moles per liter over here. But you see what would happen there? I would be doing the exact same operation to both sides of the equation, and in the end my answer is not going to be any different. So I can take a lazy little shortcut here and not bother to do that conversion, and I can just solve this the way it is. So we're going to divide both sides by our 100 milliliters. That cancels. So the molarity of the acid then is going to be equal to 0.02 times 22.5, and then divide that by 100, and that gives us 0.0045 molar. So that, as it turns out, is the molarity of the acid that we started with up here.